Students. In the previous class, we discussed about some ideal gas equation. So continuation we'll see here. Before we go for the continuation topic, let us do the revision of previous class. In the previous class, we just discussed about only 2 points. One is Gay-Lussac's law, then Avogadro's law. Then after we discussed about combined gas equation. I hope all of you must have watched the previous video. If it is not watched, then go through the channel and go just finish the videos. Yeah, first we see combined gas equation. Yes, what we have studied about combined gas equation, that is P1 V1 by T1 or N1 T1 is equal to P2 V2 by N2 T2, where these all parameters related to initial condition, means initial pressure, initial volume, initial moles and initial temperature. Yes, these all conditions related to final conditions, means final pressure, final temperature, final volume, final number of moles. Second, we discussed about ideal gas equation. Ideal gas equation, yes, what is the ideal gas equation? PV is equal to nRT. Yes, these are the topics which we covered in the previous class, and today we are going to do very interesting thing. So yes, as you go further, you will come to know what is that interesting one. So let us not reveal it. And the first topic we are going to see here, today's topic in this class, let us talk about relation between pressure and density. Pressure and density. How can we relate these two? Yes, let us see here. Yes, we can easily derive the relation from ideal gas equation. We know the ideal gas equation. As per ideal gas equation, PV is equal to nRT, right? So now PV is equal to, what is N here? N is number of moles. Number of moles means given mass of a substance. Given mass of substance, let us say symbol is small m, over molar mass of a substance. Over molar mass of substance, let us say capital M. Yes, this is a number of moles. So this is well known to you all. So this is a small m over capital M into RT. Now we are just trying to bring the relation of density. So V here and M, so we can write P capital M is equal to small m over V into RT. Now here it is the mass of substance over volume of substance, which is the density. So Pm is equal to dRT. Yes, we got the relation now. So we can say that Pm over RT is equal to density. So this is the formula to find or to relate density and pressure, right? So alternatively, we can also use this formula in a different way for different cases. So see, this is the equation 1. Let us say equation 1. For different conditions, maybe temperature is changed or pressure is changed. In that case, what can we say? Here, R is a universal gas constant which always remains constant. The remaining all are variable. So P1 M1 is equal to D1 R T1. Similarly, for a different case, P2 M2 is equal to D2, but R is always constant, it remains constant. So now if you can divide both, you can get, dividing both, on dividing, so what you will get? P1 M1 over P2 M2 is equal to D1 T1 over D2 T2. Yes, this formula can also be used in some numericals when the conditions are given. So this is about a relation between pressure and density, and here also you can say the pressure and density both are directly proportional. Pressure is directly proportional to density. So this is the topic. Yes. Now, based on this topic, let us see the previous year JEE questions. Okay, so you will come to know how to apply the concepts which we have studied so far. So whatever we have studied so far, so what kind of questions are being asked and how to apply those concepts, let us see that questions. Okay, so here I am showing the questions and try to solve it by pausing the video. Yes, this is the first question. Let us see what is the question data given here. An open vessel at temperature 21 Celsius, temperature is 21 Celsius, is heated until 2/5 of the air, 2/5 of the air has been escaped out of the vessel, assuming that the volume of the vessel remains constant. Volume of the vessel remains constant, and the temperature at which vessel has been heated, that we have to find. Yes, this is a question asked in you can see 2019 main in second shift, right? So now how can we solve it? Yes, think about it. So you must be smart enough, you can do it by yourself also, or else you can follow with me. First of all, they said open vessel. Open vessel means in open vessel always pressure is constant, right? Pressure is constant, which means P1 is equal to P2. Now what else information is given here? You can see this is a temperature, it is a temperature T1. So temperature T1 is equal to 27 Celsius. Convert it into Kelvin. How? By adding 273, which is around 300 Kelvin, until 2/5 of the air has been escaped out. Okay, so this is a vessel. So let us see, this is a vessel, and in this vessel air has been escaped out. Let initial moles, initial number of moles of air is, you can say x mole or you can say 1 mole. Okay, you can say x mole also, no problem, you can say 1 mole, but final moles, final number of moles of air left is, what is said in the question? 2/5 of the air has been escaped from the vessel. So it means 2/5 of the air has been escaped out. So which means how much will be left? 3/4, 5 mole will be left. This is the initial amount, 1 mole. In that 2/5 mole is escaped. So 3/5 mole is left. Now assuming that volume is constant, they said volume is constant, which means V1 is equal to V2. Now we have to find the final temperature. What is the final temperature T2? That is question mark. So this is the analysis of data. Okay, so yes, it will take some time, but if you practice this, you can do it very fastly afterwards or directly in the exam hall. But you have to analyze this data. Many students, especially biology group student, B group student, they get nervous about numericals. So but numericals you have to analyze like this. You can see the red lines. So in this way, if you can find out the data, then formula will be easy. Yes, which formula is suitable here? Just think about it. Which formula is suitable? Yes, that is a combined gas equation formula. as per combined gas equation. As per combined gas equation, P1 V1 by N1 T1 is equal to P2 V2 by N2 T2. Volume is constant, so V1 V2 cancel. Pressure is constant, P1 P2 cancel. Now what is left? N1 T1 is equal to N2 T2. So what is the N1 value? N1 value, initial number of moles, that is a 1, into T1, it is a 300 Kelvin. N2 it is a 3 by 5 into T2, that is what we have to find. Now it is easy question. Now T2 is equal to 500. 500, it is a Kelvin. Now, if you can see the options both are given. You see 500 Kelvin is there as well as 500 Celsius. So which one we have to select? 500 Kelvin. This is the answer. So we got 4 marks. Yes, understood this one. Yes, if you like my video, just hit the like button, and you can share with your friends also, right? So I'm moving on to the next question. Yes, question number 2. Yes, this is another question which is again asked in 2019 mains. It is again asked in 2019 mains. You can see this is a very important chapter. So what is the question? What is the data? 0.5 moles. First you have to find the data. 0.5 moles of gas A and X moles of gas B exert the pressure of 20 Pascal. The pressure is 20 Pascal in a container of volume 10 meter cube. This is the volume V and this is a pressure P. So this is the number of moles of both, and R value is given. So what we have to find, what is X? This is a very easy question. Let's write the data first. Here the given data is total number of moles. Total number of moles. N is equal to 0.5 plus X mole. Correct? And what else information is given to you? Pressure P is equal to 200 Pascal, volume V is equal to 10 meter cube, and here one point is overlooked, that is temperature. Temperature is 1000 Kelvin, and R, of course we know it, let us be R. So which formula we can apply? You just think about it and tell me. Yes, of course, the normal formula, PV is equal to nRT. So here P is 200, V is 10, and N is 0.5 plus X, and R, of course it is R only, and temperature is 1000. Yes, 3 zeros get cancelled. So 2 is equal to 0.5 plus X into R. And what we have to find here? X. X is the subject. So what can we write it? 2 upon R is equal to 0.5 plus X. So X is equal to 2 upon R minus 0.5. 0.5 can be written as 1 by 2, which is equal to 4 minus R upon 2R. That is the X value. You just look at the answers. Is there any answer? Yes, this is the answer. So got it? So this is a very easy question which is asked in 2019. Now let us go for the third question. Yes, this is the third question. Two closed bulbs of equal volume containing an ideal gas initially at pressure Pi and temperature T1 are connected through a narrow tube of negligible volume as shown in the figure below. Actually, I have not written the figure. Yes, I will draw it here. The temperature of the the temperature of the one of the bulb is raised, one of the bulb, not both the bulbs, one of the bulb is raised to temperature T2, then the final pressure PF will be. Right. So this is a very difficult question. So many students or many people have their own technique to solve this, and I have my own. So this is different method. It's my own method. Okay. So two closed bulbs. First, let us understand that with a figure. So these are the two bulbs. Two bulbs. Yes. Of a volume. Initial volume, it is a V. Of this is also V, containing ideal gas at pressure Pi. Here the pressure is Pi, and here also the pressure is Pi at temperature T1, and here also temperature is T1. Now connected through the narrow heat tube, as the temperature of the one of the bulb is raised to T2. Now what you are doing is you are heating it. You are heating, so one of the bulb, again I'm drawing the figure. Yes, here not both the bulbs, one bulb temperature is raised to T2 but other bulb temperature is T1 only. Now what is the final pressure? Here pressure will be changed in the both the bulbs. So final pressure and the volume of course is a V because it is a constant. Now how to solve this question? Think. After looking at this figure, if you can understand something, then the question is easy. What we have to find is final pressure PF is. Here one thing is very common. Here bulbs are not leaked. Nowhere the bulb is leaked, which means total number of moles of gas is constant. Number of moles of gas is constant, which means N1 is equal to N2. Am I right? And total volume is also said constant. Total volume is constant because it is not expanding, which means V1 is equal to V2. So based on this, yes, you can easily find out it. Yes, you just pause it and you try this question. Yes, now which formula we can use here? The formula which I am using is combined gas equation, P1 V1 by N1 T1 is equal to P2 V2 by N2 T2. Here number of moles is constant, which means N1 N2 get cancelled. Volume is constant, which means V1 V2 get cancelled. So now we have to find the formula becomes P1 by T1 is equal to P2 by T2. Right, this is that temperature. So now the number of moles, initial number of moles and final number of moles, we will do one thing. Yes, now I have got one beautiful idea. Let me do this question in a different way. Here let me put the number of moles N1, and here also same number of moles N1. Here temperature is changed, so number of moles it will be changed, of course N2, and here the number of moles is changed, let us say N3. Okay, so now in each case let me find the number of moles. We have the formula to find the number of moles. Let us put this one aside because this one also can be done, but it is going to be long method. I am going to give you short method. Yes, this is not in anywhere in any book, it is my own method because I have got this idea right now. PV is equal to nRT and N is equal to PV over RT. So here in the first bulb, number of moles N1 is equal to, the pressure is what? Pi, volume is V upon R is of course constant, and temperature is T1. Right, in the first bulb the number of moles is this, and in second bulb number of moles N1 is equal to, again it is going to be same, PV over RT, that formula we have to apply. Pressure in the second bulb, it is Pi. Volume is V. R, of course, temperature is T1. Now here let us find the number of moles. N2 in this bulb. Number of moles formula is PV over RT. P is now pressure PF into volume is V over R. T2, temperature is T2, and N3, so it is a PV, pressure is PF into volume is V upon R, and temperature is T1. Because one bulb only heated, the second bulb is not heated, so that's why I have to put T1. Now here you are heating it, so the total number of moles remains constant. Total number of moles remains constant. Total number of moles remains constant. So what you can do is, this is before heating and this is after heating. So before heating, N1 plus N1 is equal to N2 plus N3. N1 is Pi into V over R into T1 plus Pi into V over R into T1 is equal to Pf into V over R into T2 plus Pf into V over R into T1. Yes, here we have to find the final pressure. Yes, here we can take out a V and R as common. It is Pi by T1 plus Pi by T1 is equal to V and R can be taken as common, Pf by T2 plus Pf by T1. VR cancel. It is going to be now 2 Pi over T1 is equal to Pf is common 1 by T2 plus 1 by T1. 2 Pi by T1 is equal to Pf into, yes, it is a T1 plus T2 over T1 T2. So here T1 get cancelled, and what we have to find, final pressure we have to find. So Pf is equal to it is a 2 Pi into T2 over T1 plus T2. This is the final answer. Now let us check in the given question what is the given options. The given options are here. You see which is the option that is matching. 2 Pi into T2 over T1 plus T2. Yes, I think you see this is the option. Yes, this is the answer for the question, and this question is asked in 2016 mains. Yes, now some students ask me, sir, you have done earlier like this. Yes, let us try in this way. Some students, yes, earlier I tried by this method. Yes, you can apply this method also. P1 by T1 upon P2 by T2. At the end we got this one only. At the end, this is the P1 by T1 is equal to P2 by T2. You can try this method also, but I felt this is a difficult for you to understand. That's why I got a different source. So yes, let me explain you once again. This is the figure. Here initial number of moles, it is the initial number of moles, and here number of moles, and here number of moles. So we have to find the number of moles in both cases and add it. So as the number of moles remains constant, N1 plus N1 is equal to N2 plus N3, and you simplified and we got final pressure. Final pressure Pf is this one. This is the final answer. Okay, understood it? Yes. Now question number 4. Yes, you see this is a question number 4. First let us read the question. Which of the following volume versus temperature plots? It is a temperature volume versus temperature plot, which means this is Charles law. represents the behavior of 1 mole of an ideal gas at atmospheric pressure. So which graph is correct, that we have to identify. First, observe all the graphs. The initial condition is same, 273 Kelvin, 22.4 liter. In each case, this is the same. Now, the final condition is changed. It is at 38.8, 373, 28.6, 373, 30.6, 273, and 14.2 and 373. First of all, if you can remember Charles' law, volume is directly proportional to temperature. So here temperature is increasing, so volume should increase. So here volume is as the temperature is increasing, volume is decreasing. Obviously this graph is wrong, right? So now we have to check which out of these three is correct. Yes, I'll write answer here, just check. Question number 4. It is a, after reading the question we have got idea that this question is related to Charles law. And Charles law, what is the statement here? V1 by V2 is equal to T1 by T2. Now V1 and V2 are given in the data. What is the initial volume? 22.4 liter. And V2, it is a variable, we have to find. This is a V2, 38.8, 28.6, 30.6. Let it keep it as a variable. T1, what is the initial temperature? 273 Kelvin. And T2, final temperature is 373 Kelvin. Now V2 we have to find. V2 is equal to 373 into 22.4 upon 273. We have to solve this question. Now calculation, generally students they ask, sir how to do calculation without calculator, because in examination calculator is not allowed. So without doing calculator, without using calculator, how can we solve it? Yes, this is approximation method we call. Approximately we will say 373 as 370 into 22.5. 22.5 can be written as 22 1 by 2, which is equal to 44 by 2, correct? So can we write like this? Now this is a 45 by 2 into 273, we can take it as 270. Now 0 0 cancel, 9 3s are 9 5s are. Now it is going to be 4 5, yes, 5 7 is 35, 5 3 is a 15, 15 plus 3 it is 18 upon 2 3 is 6. So which is 31, approximately 30.9 liter. Approximately 30.9 liter will come. So you see, without using calculator we are solving the question. That is the main thing. So here you see which is the option here. The final volume V2 should be approximately 30.9 liter, in which case it is 30.9 liter, is 38.8, 28.6, 30.6. Therefore option C is the answer. Understood? So many students get confused, so these are the so many graphs, how can we do? First of all, we have to look, in each case the initial temperature is common, T1, initial volume is common, final temperature is common. So we have to find only final volume. So 22.4 upon V2 is equal to 273 upon 373, and here without using calculator we have solved the answer. Understood it? Yes. Now we will go to the next question, question number 5. Question number 5. Equal weights. Yes, this is a very difficult question. Let us see. Equal weights of ethane and hydrogen are mixed in an empty container at 25 Celsius. The fraction of total pressure exerted by hydrogen. It means we have to find the total pressure upon the fraction of hydrogen. the total fraction of the total pressure exerted by hydrogen. This is what is this value that we have to find. Okay, this is the planning. So we have read the question, we have got it. So planning, what can we do is the total pressure. Total pressure means PV is equal to nRT. We can write N means number of moles of ethane plus number of moles of hydrogen into RT over V. Is it right? Because P is equal to nRT over V. Similarly, and here pressure of hydrogen, PV is equal to again nRT, but here number of moles of hydrogen into RT over V. Here R is a constant, T is a constant, V is a constant, it get cancelled. So this is the answer. So this is the planning. Planning is very important because many students get nervous. So this question is asked in 1993 IIT. So 1993 IIT question. Okay, planning is done. So what we will do, question number 5, let the weight of ethane formula is C2H6, let us say x gram, and the weight of hydrogen is also x gram because it is said equal weights. Okay, so x gram. Molar mass of ethane, yes, you calculate and tell me. Molar mass, 2 carbon it is a 24 because carbon mass is 12. 24 plus 6, it is going to be 30 gram per mole, and molar mass of hydrogen, which is going to be 2 gram per mole. Now yes, what else information is needed? Yes, this much only. Now the fraction of total pressure exerted by hydrogen. So let us find the pressure of, actually we know the formula, PV is equal to nRT and P is equal to nRT over V, right? So now partial pressure of hydrogen is equal to, applying this formula, what will come? Number of moles of hydrogen into RT over V. Am I right? Number of moles of hydrogen. What is the number of moles formula? Given mass upon molar mass. Given mass is X. So X by 2 into RT by V. This is the pressure of hydrogen. Now total pressure. Let us find the total pressure. P total is equal to number of moles of hydrogen plus number of moles of ethane into RT over V, which is equal to number of moles of hydrogen, which is X by 2, plus number of moles of ethane, it is a given mass upon molar mass, which is X by 30 into RT by V. So this is equation number 2. We have to find the ratio. So ratio is partial pressure of hydrogen over partial total pressure. So how can we do? Divide 1 by 2, x by 2 into RT by V, divide by x by 2 plus x by 30 into RT by V. RT by V get cancelled. So x by 2 divided by x, we can take it common. It is going to be 1 by 2 plus 1 by 30. X get cancelled. It is 1 by 2 divided by LCM is 30. 30 plus 1. It is so it's a 15 plus 1. 16 divided by 30. And it is a 2 ones are 215. So which is equal to 15 by 16. So the ratio is 15 by 16. So yes, any option is there? Yes, this is the answer D. Understood this question? So it is said that equal weights of ethane and hydrogen are mixed in an empty container. So equal weight I have taken x gram ethane, x gram hydrogen. Molar mass 30, 30. Partial pressure of hydrogen. Pressure is equal to nRT by V. So number of moles of hydrogen into RT by V. And similarly total pressure means total number of moles. And we have divided both and we got the answer. Right? So I hope you understood this question also. Right, now moving on to the next question. Yes, now next question. The density of neon will be highest at This is the 1990 question. It's asked in 1990 IIT question. Yes, density of neon. So yes, what is the formula that we have studied in this video? Density is equal to uh, PM over RT. In this question it is said neon. So neon means molar mass is constant and R is also constant. So in this, from this formula I can say density is proportional to P over T. Can we say like this? Now let's take first option, STP. What is the STP? Pressure. Yes, it is a atm. 1 atm upon temperature, which is 273 Kelvin. For second option, what is the pressure? We are writing pressure over temperature. Pressure is 2 and temperature is 0 Celsius, which means 273 Kelvin. Now third option, pressure is 1 atm and temperature is 273 plus 273, which is going to be 576. Okay, so now next one, pressure is 2 atm and temperature is 273 plus 273 is a 546, not 576. It is a by mistake. I have written 546. Now which is the bigger value? Density is proportional to P by T. You tell me which fraction is the bigger one. So this is, you can cut it. 2 ones are 273. It is a 1 by, of course, 576. So which fraction is a bigger one? Yes, I think 2 upon 273 is a bigger number. It is a 1 upon 273, it is a 1 upon 273, it is a 1 upon 546. Therefore, this answer, this is the right answer. Understood this question? Yes, if you like it, you can put, you can subscribe my channel, and if you don't, if you have any problem, you can write in the comment box and I'll come to you. Yes, now next question. Yes, question number 7. Question number 7, equal weights of methane and hydrogen are mixed in an empty container at 25 Celsius. The fraction of total pressure exerted by hydrogen. I think this is the same question which we have studied right now. So that's why I'm not solving this question number 7. Now this one, question number 8. Yes, these are subjective questions, not objective question. Yes, you see, this is a very tough question. Mixture of ethane and ethene occupies 40 liter at 1 atm. Mixture of ethane and ethene, it's not said equal weight, it is a different weight, occupies 40 liter at 1 atm and 400 Kelvin. The mixture react completely with 130 gram of oxygen to produce CO2 and H2O. Assuming the ideal gas behavior, calculate the mole fraction of ethane and ethene in the mixture. Right, understood? So we have to find the mole fraction of ethene. How to find mole fraction? Mole fraction is equal to number of moles of ethene upon total number of moles. Right? So if you can get this one, this number of moles, then the question will be done. So we have to find number of moles. How to get number of moles? The mixture is given here. In the mixture, this total volume is given. So planning is, you see, the plan to solve this question is, first let me find the total number of moles. Total number of moles of ethene and ethane. First I want to get this, and in that I will get x moles of this one, and this one will be the total number minus x, or I can say that y moles, and this is reacted with oxygen, to produce a CO2 and H2O. Based on that I'll get some answer. Okay, so maybe some confusion is there, so don't worry, just go through the video, you will understand very easily. Yes, as per the given data, what is the total volume? Total volume is 40 liter and pressure is 1 atm and temperature is 400 Kelvin. Now number of moles I will get. Number of moles, what is the formula? PV is equal to nRT, and N is equal to PV over RT. So P, pressure, pressure it is given 1, volume is a 40, R is 0.082 into T is 400, right? So this get cancelled, so it is going to be 10. So 1 upon 0.82, 1 upon 0.82, let me write like this, 100 upon 82. Can we write like this? Approximately, let me do in approximation method. So this I will take it as 80. So 24s are 25s are, so it is going to be 1.25 moles, but approximately I will take 1.2 mole. What is this 1.2 mole? This is the total number of moles. Total number of moles of ethene and ethane. Total number of moles. So number of moles of ethene plus number of moles of ethane is equal to 1.2 moles. Now let the number of moles of ethene as x mole, and this one will be 1.2 minus x mole. Yes, this is x mole and this is 1.2 minus x mole. Now this is made to react with oxygen. Okay, so now we will react this one with oxygen. Let me convert this question into grams, because in the given data oxygen mass is given in grams. So x moles of ethane is equal to how many grams? Give number of moles is equal to given mass upon molar mass. So which implies given mass is equal to number of moles into molar mass. So here x mole, so weight is equal to number of moles is x into molar mass of ethene. So 24 plus 2, 28. So this is going to be 28 x gram. 28 x gram. And this one, so again weight is equal to number of moles is 1.2 minus x into its molar mass is 30. So it is going to be 1.2 minus x into 30. So grams. This is the weight of ethene and ethane. Now let us put the equation. Equation, it is C2H4 is reacted with oxygen to give CO2 and H2O. Yes, balance it. It's a 2 and 4 hydrogen, so you can put 2 here. 2 to the 4 plus 2, 6, it's 3. As per this equation, it is a 28 gram of ethene reacts with how many grams of oxygen? Oxygen molar mass, it's 32 into 3. 32 3 is 96. 96 gram of oxygen. How many grams of oxygen with us in the given question? Ethene is 28x. 8 gram of ethene will reacts with dash gram of oxygen. So find out that. Therefore amount of oxygen needed is equal to, amount of oxygen needed is a cross multiplication, that is a 28x into 96 divided by 28. 28 cancel, so which is equal to 96x. This is equation number 1. We have reacted with ethene. Now we have to react with ethane. Okay, now ethane is a C2H6 react with oxygen, it gives CO2 plus H2O. C2, we can put 2 carbon, hydrogen 6, we can put 3 here. It is a 2, 2 is a 4 plus 3, 7. So we can put here 7 by 2. So if this mass is 30 gram, what will be its mass? 7 16s, I think 102 gram. So as per equation, 30 gram of ethene react with 102 gram of oxygen. How much amount of ethene we had? That is 1.2 minus x into 30 gram of ethene will react with dash gram of oxygen. So here, so amount of oxygen now, amount of oxygen is equal to 1.2 minus x into 30 into 102 divided by 30. 30 get cancelled. So it's going to be 1.2 minus x into 102. This is the oxygen needed. Now total amount of oxygen needed. Total oxygen needed as per the question, it is 130 gram. And as per our data, it is 1.2 minus x into 102 plus, and initially how much amount it has come? 96x is equal to 130. Now simplify it. It is 1.2 into 102 minus 102x plus 96x is equal to 130. So 1.102 or 10.2 into 12, 12 to the 24, 12 0, 0 carry 2, 12 ones are 12. Yes, it is a 122.4 minus, it is a 6x is equal to 130. Now 6x is equal to 122.4 minus 130. I think answer is coming negative. Negative means somewhere we are wrong. Okay, let me check the mistake. It must be this one. Okay, 16 sevens, it is 112 gram. Okay, so this is 112 gram. So here it is going to be 112. It is 112 now. 112 into 2, it is a 134.4. Yes, it is a 134.4. Now it is a 134.4 minus 30, which is equal to 4.4. Yes, 4.4. X is equal to 4.4 upon 6, which is 0.67 are 42, 20 is there, 6 3s are 18, some carry. So this X is 0.73. What is X? That is number of moles of ethene is equal to 0.73. The number of moles of ethane will be 1.2 minus X, that's a 1.2 minus 0.73, which is equal to 0 minus 3, it is 7, 11 minus 7, it is a 4, 0.47 mole. Now what is asked in the question? We have to find the mole fraction. So mole fraction means X of ethane is equal to number of moles of ethene upon total moles. Total moles, which is 0.73 upon 1.2 total moles. Similarly, mole fraction of ethane is equal to number of moles of ethane over total moles, which is 0.47 upon 1.2. You solve it, you will get the answer. So this is a subjective question. IIT previously it was a subjective one, so it's a long question. And yes, if you have a doubt, just rewind the video once again, you solve it. And this kind of questions are asked in recent IIT examination also, and even AIMS exams also. AIMS means NEET, right? Now, next, the remaining questions are here. It's about question number 9 to 13. I'm leaving to you guys. You solve the question, and if you have any doubt, you put it on the comment box. I'll explain those questions in the next lecture. Right? Thank you very much. Take care and see you in the next class.